We're good to go.
Great, thanks, Sandy. So, yeah, let's go ahead and introduce Mark and Scott. So, Mark Charney has been with HPE Aruba since 2013 with several different positions, including senior sales engineer on major accounts. He's also been hospitality team for over 5 years, focusing on strategic integrations, analytics, data science, and working with our key partners or their key partners and customers to operationalize API endpoints as they build up their own dashboards and workflows. So Mark's experience in industry spans back over 20 years, back to Symbol Technologies and Motorola Solutions. His most recent work focuses on wireless LAN optimization, AI for networking, improved connectivity, and guest experience. So thank you, Mark, for joining us. And then Scott Fain, who is with us as well, is the manager of hospitality systems and engineering at Ruckus Networks. He lives in Northern Virginia, DC area, and has been in the networking technology industry for almost 30 years, and with the last 13 of them at Ruckus. When he's not working, Scott and his family enjoy taking their RV and his big Ford truck out to campgrounds around the country and checking in at all the sites and the Wi-Fi if they have it at these campgrounds. So I guess that's a real thing from what Scott says, which is good. And so we are excited to have you guys both with us today. Thank you for taking on this great topic. And with that, I'm going to hand it over to Scott and Mark.
Thank you, Steve. Appreciate the introduction there. Mark and I are just going to sort of bounce everything off of each other, but we did this presentation, about 2 months ago, I guess, in Philadelphia. And as Sandy said, it went over really well. And I feel like we want to bring this to a wider audience, because there's just an opportunity to sort of reset how technology is moving forward in hospitality specifically. So, Sandy, why don't you go ahead and build this one all the way out? We'll just walk through each individual part of the slide. So I think before we move forward, we have to talk about the past. Like, we always need to know where we came from to know where we're going. And as we all know, Wi-Fi started small, but it was very exciting to be able to walk around, obviously, without being attached. And the first, 10 years or so were pretty interesting, right? Things moved quickly, but there were a lot of devices that were being made and being added, but it was a science experiment, right? It was very difficult to get online. It was very difficult to stay online. And so, as we moved through this portion, from 1999 until about 2008, back then it was called 802.11ab and then G and then N, and we are all familiar with all the speeds and feeds and putting cards in the side of our laptops and Blackberries and etc. And it was very interesting time. It was a very fun time, and we learned a lot through that experience. And ramp up was slow. And then when Wi-Fi 5 or 802.11ac came out, it really sort of brought the masses. I think this is around the time, in the 2009 timeframe, iPhone hits and then Samsung comes out and all these other things. And so we started to hit this ramp where more people have access to Wi-Fi devices. And it's really important to make sure that, we get them all online. And I think there's one thing that, back in the AC days that really came to light was, how can we get more and more people online? And so it took, the better part of 15 years to get the first 10 billion devices globally online. And then, once, late 2018, 19 hits, we start hitting Wi-Fi 6. And almost everyone has at least one device, if not two or three. And the ramp is just super fast and super high. And Wi-Fi 6 comes along and it enables this type of ability to add more and more devices. And so in about 6 years, 5 to 6 years, we're going to add double the number of devices that we had in the first 15 years. And I think this is just what we all know. It's the hockey stick, right? It goes straight up. So we've moved into these protocols, as time has gone on, and it's putting, more requirement for network efficiency and capacity and other things. And we have to make sure that we stay prepared for this moving forward, to make sure we aren't the problem in the bandwidth and the capacity, moving forward. All right, so go ahead, Sandy, next slide. Oh, Mark, you got anything for that one?
Yeah, I mean, the only thing I wanted to add is I think you said everything right there. I just wanted to make sure this is pervasive, right? Not just in hospitality, but throughout almost every industry, right? The expectation is we're not even talking about wired devices today. All new students, children, people entering the workforce, there is no perception of anything wired anymore. I mean, Scott and I are aware of all that. We could get a wired devices, no problem, but it must be wireless. There is no question about it. It has to be efficient and it has to work.
Yeah, exactly. So as we've moved through this, what we call the speed evolution, we talk about, the difference. Now let's just call it, what we all have retermed and back termed, Wi-Fi 4, 5, 6. And we see the huge jump, as I mentioned, to get to Wi-Fi 5. It was absolutely imperative that we get there because of all the devices that came online, starting with the iPhone, right? And luckily, the technology was able to capture it, because if the devices outpaced the technology, we'd have been in a bad way. And luckily, we were able to keep up. So we immediately hit this huge speed gap. And probably one of the most efficient and stark contrasts between those is that everyone immediately had like you could do real things on your device. And that's thanks to the speed uptake. And Wi-Fi 5 is great. It's still very pervasive. There's a lot of Wi-Fi 5, not only access points, but devices out there. But moving forward, we couldn't just stay there. We had to move even further, because what happens, like anything else, is you have more and more devices and you can't make time. You can only use the time that you have as efficiently as possible. So when we move from Wi-Fi 5 to Wi-Fi 6, you're like, well, that's only a 1.3 times speed increase. It must not be very efficient. It must not be very good. But as we'll see later, there's more that happens between Wi-Fi 5 and Wi-Fi 6 for the ability to sustain these networks than probably happened between Wi-Fi 4 and 5. Wi-Fi 4 and 5 was just a big motor, right? We just put a big motor in the thing and we're just going to haul. When we get to Wi-Fi 6 and forward, we're making everything we have more efficient, because you can't make time. So we'll go into this a little bit further, but and then the move from Wi-Fi 6 to Wi-Fi 7 is going to be a pretty substantial jump as well, not just for bandwidth, but for unlocking the potential for all of the clients that have time. How efficiently can they use them? And you'll find that the raw speed increase may not look very, very, very big, but the ability to harness that time and use it to its capacity will show that we need to keep this in mind moving forward.
Yeah, and I would just add, the only thing I want to add there, Scott, is I think you clarified it well. Those numbers, those are sort of the marketing numbers, right? Obviously, we're not going to get to some of those things on those are theoretical numbers. But even if you take portions of those, right, half of that or even a third of that, those are huge increases. And I think what's happening in the industry is, certainly from a hospitality standpoint, customers, guests are going, hey, I've got a Wi-Fi 7 device. I should be able to run my iPhone and device at these speeds and be able to, at least have as good as I have at home, if not better. And so we need to think about, that's what some of this discussion is what does that mean? How can you get there? Does it make sense? All right. So we'll talk through some of that.
Okay, next slide, please. So I won't belabor these points, but anyone who's seen sort of this graph understands that the move from Wi-Fi 5 to Wi-Fi 6, AO2.11ax was a huge jump, and it's because like I said, we had to focus on, we can't make more time, we have to make the time we have more efficient. Also, the battery life of everyone using their devices, we have to keep this in mind. So when Wi-Fi 6 came along, there was a lot of things that went into the protocol itself to be more efficient. Obviously, they were working to extend battery life, but network capacity is a huge thing, because now we have more devices that are capable of doing more things. So we had to spread, the frequencies out. We had to make sure we use them well. We also had what's called BSS coloring, which is like listening to, we have a finite number of channels and a number of APs in the same space. They're going to have overlapping channels sometimes. So BSS coloring is sort of like subchannels. You know, we have the same channel on 2 access points, and the clients can differentiate as the one they need to listen to as the one they're listening to, and the other one is noise. And so they can sort of focus, like listening to a conversation. Multi-user MIMO is basically just like the ability to have multiple clients share the same time space, and communicate at the same time, and the access point be able to listen to basically 2 conversations at the same time. And then, you know, one of the biggest things is what's called 1024 QAM. This is the size of the highway. Widening the road, if you will, having more ability to take the time you have and expand it. And we'll see later how this affects Wi-Fi 7 moving forward. So just remember 1024, just keep that one in your head. Yeah, go ahead, Mark.
No, the only thing I would add is the OFDMA was interesting as well, right? Because we took some of the efficiencies of cellular and LTE and kind of moved that into the Wi-Fi space to be able to, as Scott talked about, I need to be more efficient, right? The only thing I can't get back is time, so I got to be more efficient with it, and that gave us another ability to do that from a Wi-Fi standpoint.
Yeah, exactly. All right, with the next one. So this is kind of a cool graphic. You know, the difference in Wi-Fi 5 and Wi-Fi 6 is we're basically filling the truck to its capacity, right? Making more efficient usage of the time that we were given. We don't want to let time go by, right? We want to use it as best we can. So there's a lot of the protocol, part of what Mark just mentioned, the thing that, how is it that we can have thousands of people standing within a 5-mile range of a cell tower? How is it we can all get on there and get what we need to get done? Well, all those efficiency protocols came out of the cellular space, right? And the ability to pack more tightly everything we need into that time space is hugely important, and really what gave Wi-Fi 6 the bump that we really all needed. Because, you know, straight horsepower when you're standing right under the AP by yourself, no problem. When you get tens or hundreds of people standing around an access point, how are we going to get those people on and off the air efficiently enough so that no one is unduly latent with the data that they're trying to download or upload? So, right. The next one, please. Okay, so here's why we're all here. You know, Wi-Fi 7, and really, I would even say, you know, Wi-Fi 7 and beyond. You know, if you've been watching, you know, for better or for worse, Wi-Fi 8 is around the corner. So let's just call it Wi-Fi 7 and beyond. Because I think really it's still sort of the same thing. It's we still can't make time in a bottle. So if you could, you know, that'd be a heck of a you know, a business to get into if you could sell time in a bottle. But since we can't, we're going to have to use what we have. And so as Wi-Fi 7 moves along, as you can see, so Wi-Fi 6 and Wi-Fi 6E, as we all know, 6E is basically just the addition of 6 gigahertz band, but it uses the same protocol as Wi-Fi 6. So it's a great bunch of open space, but it doesn't really move the needle as far as, you know, the efficiencies and everything else. It's just sort of adding lanes to the side of the road for like an express lane. But moving forward, we're going to use that space and use it even more efficiently, just like we're going to move from 2, 4, and 5 to Wi-Fi 7. So as you see here, Wi-Fi 6E is a bit of a sliver, and we're going to move forward with Wi-Fi 7 and beyond. And I think, you know, some of the things that we need to be aware of is, you know, there's still a lot of Wi-Fi 6 out there, still a lot of Wi-Fi 5 out there, but we can keep moving with it. Anything we have as far as a protocol wise is always backwards compatible. So it's not like you have to throw anything in the garbage. We're going to keep using what we have, but we're going to make everything that's new more efficient. So Wi-Fi 6, you know, we expect it to be a long tail through 28 and 29. Obviously, you know, people are going to hold on to equipment. There's going to be no problems there. And then, you know, when we move into the 6 gigahertz bands, that's a huge chunk of spectrum that's now available to us. And we there's been some discussion we'll hit in just a second about the availability of that band, but Wi-Fi 6E and Wi-Fi 7 are both, 6 gigahertz capable, and moving forward, obviously, we'll get to use that space. We think, obviously in certain areas where high density, think Wi-Fi 6, sorry, think 6 gigahertz, think high density, education, higher education, hospitality, think of the ballrooms, think of the large public venue spaces, the
Convention
bar on,
centers, convention
yeah,
centers. Yes.
yeah,
Yep.
the bar during the hospitality show, at night. We know that gets to be a very dense place, right? And large public venues and et cetera. So there's going to be a lot of use for the 6 gigahertz, even in hospitality. So we don't want to, we want to make sure we use it efficiently. So go ahead, Mark.
Oh, the only thing I would add here is I just want to make sure that there's an understanding that 6E is a sliver there, right? We don't expect a lot more 6E, both client and APs, but those that did deploy 6E to get in some advantage of some of the, early 6 gigahertz spectrum and even today, that will still be workable, right? That still makes sense. There is no negativity around that. Even new Wi-Fi 7 clients will be backwards compatible. So just wanted to make sure that that wasn't, because I know sometimes that comes up. Hey, do I need to quickly move and get rid of even my 6E, right? And so we'll talk through some of that.
Yep, exactly. All right. So this is sort of the same graph we showed for Wi-Fi 6, but we'll look through, what makes Wi-Fi 7 different. So remember I mentioned 1024 QAM. Now we have 4,000 QAM. So we've taken what we thought was a pretty wide highway and we've quadrupled it. So now with the same amount of airtime, we've quadrupled the amount of bandwidth that can run in that same space. So 4K QAM is a huge deal, and that is really going to push the bandwidth, the straight, just raw horsepower, through the access points, which allows us to now have more spatial streams and now even wider channels. So the idea of limiting yourself to 20 megahertz channels and something short of 100 megs maybe actual throughput. Now we can double that. We don't probably see a lot of 320 megahertz channels, but what it does is, since we aren't limited by 160 megahertz like we had been, we can now move to maybe 40 or 80 megahertz, which now the actual client to AP bandwidth is now doubled or quadrupled. And it's just a sliding upscale, right? So everyone moves up a little bit and has the ability to have more bandwidth at their disposal. Punctured transmission is another huge thing in Wi-Fi 7, where if you had a 40 megahertz channel, it's two contiguous 20 megahertz channels. If there's interference in that channel, that whole channel has to break apart. Whereas with punctured transmission, you can make a 40 or an 80 megahertz channel of non-contiguous channels. So what that allows is the ability to, now you have interference, the AP registers interference in the middle of an 80 megahertz channel. Well, it'll just work around it, right? It's like traffic cones, and the traffic will just move around it and it'll just keep rolling. That's a huge thing, because now you don't want to hop off that entire 80 megahertz channel to another complete channel. You just want to work around it. It's going to be much more efficient moving forward. And then,
and you think of events like radar or other events that caused channel issues. This is going to be a huge advantage for throughput, as you talked about, being able to really use the spectrum efficiently.
Yeah, absolutely. So the multi-link operation is going to be a fun one. So obviously the ability to span different bands has not been available to us in the past. So if you were on 2.4, you were on 2.4. If you're on 5 gigahertz, you're on 5 gigahertz. And we all wanted to be on 5 gigahertz because A, it was less noisy, there are more channels, and it was higher bandwidth. So like turn 2.4 off, we're done with it. And then 6 gigahertz comes along, you're like, yep, I definitely have no more use for 2.4, just turn it off. Well, then we come out and now we have the ability to span different frequencies at the same time, different bands. And now 2.4 comes back into play. So now if I want to use the most efficient ability to use the air, I can now straddle 2.4 and 5 and have my device run concurrently over both. in any two of the three bands. And so now 2.4 could come back into play. So we don't want to turn it off. We probably still want to look at it efficiently. But when you have a tri-band access point, you're like, okay, we'll straddle 5 and 6. That'll be fine. But there's going to be a lot of use cases for dual band access points that are only going to be running in 2.4 and 5. But the ability to use both of those at the same time comes back into play. And I think that'll actually be very interesting in the industry, especially in hospitality, where we probably are going to still not get rid of 2.4. So, Mark, anything on that?
No, no, I think you covered that well. The only thing I would add is something around IoT will be important in that space, right? Because we're going to start seeing more, maybe some IoT devices move
Mm-hmm.
more into the Wi-Fi space just from an efficiency standpoint, a management standpoint. We hadn't even talked about some of the additional components like location services and GPS that make IoT a lot more efficient as opposed to just pure BLE today. So yeah,
Yeah.
definitely running and carrying over Wi-Fi.
Yeah. And then last in this box is the enhanced quality of service, right? Obviously, if your packets are showing up out of order, or you're losing packets, things like full motion video are going to be grainy, they're going to be pixely. Video calls like this are going to be like, you're not going to want to hear this. So just more QoS, just more making sure that things show up on time. There's an extra effort into the QoS part of the protocol.
Yeah, and the only thing I would add there, Scott, is I'm starting to see, and I don't know if you guys are seeing this, but certainly with a lot of in hospitality, especially, there seems to be a real interest in new properties or new, very boutique style operations, adding almost like VR capabilities, right? They're enhancing, the guest experience and really trying to push video augmentation and VR. And so that when that comes out, obviously, anything in the 6 gigahertz space, but especially taking advantage of some of the Wi-Fi 7 capabilities will be huge, right? So that's going to be critical to this.
Absolutely. Okay, next slide. All right, Mark, this is you.
Yeah, so I can switch over. Thanks, everybody. Do we want to? I don't think there's anything in the chat, so let's just keep going here. Um, from a 6 gig standpoint, as Scott kind of alluded to, this kind of started out in Wi-Fi 6E, and we started adding the 6 gig capability, potentially 1200 megahertz availability in the US, different in some of the other countries. But as you can imagine, it was very clean space, so super excited to take advantage of that. Hence the reason that the 6 gigahertz got very excited, and we had a lot of devices moving in that space. Yeah, next slide, Sandy. Right. So I could probably spend almost the rest of the time on this one slide, but let me just try to recap a little bit before we kind of move forward. If you can imagine, we talked a lot about the speeds, right? The super increase in Wi-Fi 7 speeds, potentially in the 40 gigahertz, 40 gigabit space. That's huge. All right. And so those kinds of things and efficiencies lend themselves to how can you really achieve this, right? So we had a period of time, especially in the hospitality environment, across different properties and so forth, where, I think, and Scott would probably agree with this, you would upgrade APs and you could get efficiencies in your network and get better throughput in the Wi-Fi, and you really didn't have to worry about the infrastructure as much. Maybe you had some power challenges, and maybe you had to wait to kind of do intelligent power management or something like that on the APs themselves. But for the most part, you could get, double your increase and not really oversubscribe both the ports and the switches, right? But now we're kind of in a bit of a challenge, right? If you think about the AP being able to support theoretically, let's just say in reality, even 10 gigs coming across there, I cannot have just a 1 gig Ethernet pulled to the AP. I've got to have a 2.5 gig port at minimum, maybe even a 5 gig. right? So that's number one, which means you've got to kind of change some of your cabling and so forth. Number two is what do I do about those switches, right? From a power standpoint. We haven't talked a lot about the power here, but the Wi-Fi 7 APs are going to require more power, potentially PoE++ could be up to 60 watts. That changes your switch requirements because I've got to figure out how to provide more power to them. I had started talking about the other challenges, if you can imagine, kind of, and we're going to talk through some of this from the IDFs up to your core, right? A lot of environments still have IDFs that are doing, lagging one or two strands and sometimes doing almost 1 gig uplink. So they're lagging, they're basically doing 2 gig to the core. Your IDFs are going to be oversubscribed when you start pushing Wi-Fi 7 clients through those access points. So you start adding all that in. What it ends up getting down to is this sort of infrastructure breakdown, right? In the past, it was, it might have been 85% access points and maybe some cabling updates. Now I've got to think about switching infrastructure changes. I have to think about cooling and power. I have to think about cabling. What does my OM environment and my fiber environment look like? I've got to upgrade for power and installation. So the Wi-Fi 7 kind of picture has a lot of potential benefits, but we're sort of at an inflection point, and you want to make sure we're not negative on Wi-Fi 7, but it's not a simple, you just replace the access points and you don't have to talk about anything else. It takes some planning, design, thinking, and so forth, right? So, I mean, I'll just give you some anecdotal data, and some of the folks on the call may be familiar with this. I've actually had two customers in the hospitality space who upgraded their APs to Wi-Fi 7, didn't do anything else in their environment, and ended up getting frustrated over the situation because they really didn't see a speed increase for their clients. And it kind of makes sense, right? Because they didn't invest in the rest of the infrastructure. The other thing that happened to another customer was something similar, but they ended up finding an issue in oversubscribing their IDF switches for a similar reason, right? They only had 1 gig links, and they had actually lagged 4 1 gig links together, so they had 4 gigs to the core. But even so, that's not even close to what you would need from a Wi-Fi 7 standpoint. So, right. So I think this kind of gives you start thinking of cost benefit, where it makes sense, in a select service environment. Do I need to go to Wi-Fi 7? Maybe not in resorts or more, sort of midline hospitality. Maybe I'm kind of thinking through those requirements depending on timing and inflection and where I am in upgrades. That's kind of the point of this slide. So, Sandy, if
Yeah.
you could go to the next one. If you
Well,
want to add
for
something,
you,
Scott. Yeah.
yeah, before you jump. So I think, the important thing to realize is sometimes one size doesn't fit all, right? So when you say, should I go Wi-Fi 7 or should I not? Well, hotels are very diverse places, right? And very diverse types of hotels, right? So you could have a very small hotel that basically services business, guests, and they take a call from their room, and then they go off to a meeting, and they come back, and they don't really, other than updating their email, they're probably not taxing the network. However, you might have the opposite of that with 100,000 or 200,000 square feet of conference space in a hotel. That's a completely different scenario. And not only that, the different parts of the hotel are different scenarios, right? So that the guest rooms may have one profile, if you will, and the conference space may have another profile. And it's okay to mix those. So, when you're talking about technology, you put different size, networks in different size places. So you can, and this is gonna get to Ron's question here in the chat, is 10 gig enough? Well, in certain areas, you can upgrade to 10 gig or 25 gig on your uplink switches. Or if your APs need up to 10 gig for a select number of APs. While all that's happening in the guest space, you could still be doing your 1 gig and being happy, with the access points that are sitting dormant most of the day because everyone's in the conference room. So I think it matters, your perspective. And like I said, not one size doesn't fit all, but I think there's still the ability to engineer an actual solution, not just, blindly upgrade. So there's
Yeah,
definitely
yeah.
some things to think about, decisions to make.
Yeah, I think I would add on you when we say Wi-Fi 7, to your point, it doesn't mean that you must have Wi-Fi 7 everywhere or take advantage of all the components of Wi-Fi 7. Maybe you even, to Scott's point, you put Wi-Fi 7 APs everywhere, maybe, but I decide on infrastructure on where I'm going to do upgrades and guest rooms in different places, as long as I have expectations on, what I'm doing in the environment, right? Or to your point, maybe I do, maybe we're at this inflection point now where I kind of mix and match depending on what my needs and requirements are, right? And from a vendor standpoint, they're very easy to be able to mix and match and manage effectively, right? That's not a stopping point in any way.
Yeah. All right.
Yep. Yep. So this is great. This is probably the takeaway. We've probably talked through some of these things, right? Hotel owners are going to have this challenge around where am I in my timing? Am I ready? Am I already ready for a refresh based on, brand requirements, based on the ownership groups, right? Boutique versus select service or mid-tier, right? This is going to be a question that we talk through, right? Do you have conference space, right? This is going to be a critical question that I think manufacturers and sort of technology consultants can help with this. And I know a lot of people on the call and meeting are kind of in this space. This is the expectation that I would hope we would all be kind of working towards, right? And I think if you think of kind of the bell curve, right? Wi-Fi 7 from a technology standpoint is very mature. But what it brings back is some of the challenges around the infrastructure, right? And hence this idea of where are you? Are you ready to move forward completely and change out the entire infrastructure? Probably not, but it just depends on timing and so forth. And so I think a lot of it really requires proper planning, proper financial cycles. What's the expectation? I know there's a lot of people thinking, Wi-Fi 7 means I get 10 years of investment protection. I think a lot of us, and I don't know if Scott can jump in on this, that's also a challenge today. There are some people thinking, well, if I update all the infrastructure and I put in Wi-Fi 7, I'm good for 10 years. Well, I don't know. We don't know what clients, what applications, what the drivers are going to be, right? Wi-Fi 8 is going to be a lot about efficiency, but there'll be things even beyond Wi-Fi 8 that could change things a little bit, right? So, and I think from an operations standpoint, it's important to set expectations, as Scott alluded to earlier, right? What do I need in the guest rooms versus conference versus meeting versus restaurants, those kinds of things.
Yeah. I think it's the right time to ask questions. I'll say this,
Yes.
as
Yes.
a hotelier, you have, the opportunity to say, okay, where have I been the last, especially in an older property, what's my infrastructure look like? Is it the right time to think about investing moving forward? Because I can take advantage of that investment. And will that give me my 10 to 15 years of investment protection? So I think that's key for what we have on the slide here. The everyone has their part to play. The hotel owners, the technology leaders, and the operations teams, they all have a different view of this. And I think we all need to come together and help these groups understand not to overinvest when not needed and not to underinvest when it's absolutely needed. Right. All
Yeah,
right.
we can go to the next
Yeah.
slide. But the other thing I think it also, yeah, we'll get to the infrastructure pieces, but it also opens up. We haven't really talked about revenue and RevPAR and different things, but there is potential for additional revenue streams around conference, around guest experience that things like Wi-Fi 7 open up. So it's not just around the infrastructure investment. So yeah, let's go to the next slide. Do you want to take this one, Scott, and I'll kind
Sure.
of jump in?
Yeah.
Okay.
So obviously with greater technology and greater ability comes more power. So it's we need more power. So You know, I think that, you know, you definitely look at the spec sheets for all the vendors who we all have access points, and we're going to give you, you know, the max power that's required. And I think that, you know, we need to heed some of these warnings because there is more power being drawn and there's more power, there's more clients attaching to these access points. And because of that, we're going to bump. We may not bump as high as, you know, the maximum, but we're definitely going to see us clip to the next level. So in the past, if you used a dual band access point that ran on 8, 9, 10 watts, you might find that that access point goes to 15 watts. So dual band access points are probably, you're going to be looking at, you know, the 802.3 AT. So you might be looking at 16, 17, 18 watts. So that's a power slot that you may have not anticipated. The tri-band access points are almost always going to be at least 30 watts. You're probably going to need what's called 802.3 BT power, which is up to 45 watts in most cases. Those are different switching technologies that you're going to have to invest in most likely to get the most bang for your buck. You can buy an access point and run it into the lower mode, but then is it worth spending the money on a higher end access point if you're going to lower the power and not let it run to its potential? I think it's very, very critical that you understand the technology and understand the access point you're purchasing and why you're doing it and run it appropriately. So if you look at across the board, you know, 10 dual band access points is now 300 watts, whereas before it might have been 150 to 180 watts, right? 10 tri-band APs is now 450 watts. So there's other things to consider: larger electrical circuits in the closets, more UPS power, possibly more cooling, more space between things. Like, we know a lot of racks are in the the housekeeping closet. Sorry.
Yeah. Yep.
And there's stuff piled up against it, and that stuff, the equipment's going to run hotter. We need to make sure we keep the infrastructure cool. We need to make sure we keep it, you know, viable for the long term. You know, you want that switch to last 10 years. You can't put towels and sheets around it in all ways, right? So there's a couple of technologies that are helping with the PoE power increase. Dynamic power, I think most vendors have some version of dynamic power where the AP will ask for a certain amount and then settle in at a certain amount. That usually will work. But that's not supported in all switch vendors and all models. So you have to look into, you know, what you have there and make sure that you're buying the correct equipment.
The one thing I
All
would
right.
add
Yeah.
from a value engineering standpoint, based on what we talked about, right? Maybe you're putting Wi-Fi 7 in, you know, in conference spaces, large public space areas, in which case maybe you only need these switches uh, powering those access points. So again, something to think about from a inflection point, a planning, a value engineering. It goes back to that other slide about the different teams and the different operational areas, right? That's definitely a key point here as well.
All right. Next slide. So with more edge capacity at the access point, now we might need more trunk capacity out of the closets, right? So in the past, you know, we could run 1 gig uplinks out of the IDFs into the MDF, but look at the tri-band you know, access point abilities, right? They can do 1.5 gigs by themselves, just one access point. So if we're looking to aggregate, you know, more APs on a switch and more clients talking to those APs, we most definitely can move over 1 gig. That's going to probably be the norm. And in fact, you know, in some cases, 10 gig may not be enough. So if we're in a conference space, we may be looking at, you know, maybe 10 gig would have been the norm in the past. When you have a really high end conference and everyone's hitting the network hard, you may be pushing 6, 7, 8, 9 gigs possibly. You know, so it's possible that not only could you get to 10 gig, there's other technologies above it, 25 gig and further. So it's just something to keep in mind that you know, the infrastructure, the ability of the network is moving up, right? More infrastructure is going to be needed up the stack, and we'll have to keep that in mind as you move along.
I think the only other thing I would add is this is really the first time in Wi-Fi where when we're adding or using an access point, we are literally pushing past that 1 gig typical uplink for an access point. In the past, even with Wi-Fi 6 and AX, we really didn't, as you moved a lot of clients across it, you just didn't go past the 1 gig very much, if at all. Now you're really definitely doing that from a Wi-Fi 7 standpoint, right?
Yeah.
Hence the infrastructure discussion.
Yeah. All right, next one. So this is really where the rubber meets the road, right? So you go to a hotelier, and if you're a hotelier, you go, all right, what do I need to do? Tell me what I need to do. Well, 1 gig, you're still fine on whatever you have installed. So as I mentioned before, a Wi-Fi 7 access point doesn't necessarily mean I have to put new infrastructure in. If I'm planning on using it at 1 gig, if it's just an access point in a room, most likely it's not going to need to go past that. And I had Cat 5e pulled, I could probably use it. It has to test out well. It has to be able to support the extra power, but most likely it's going to work. And it could even work at 2.5 gigs. It's not the best use of that, but if it tests out properly, it should test it at 100 megs at 2.5 gigs. Now, moving forward, when we start talking about these larger access points for the conference space and public spaces, you're absolutely going to have to be in Cat 6 or above. And Cat 6A is probably the way to go. If you've invested in Cat 6A, you've done the right thing. There's still the distance at 10 gigs is 100 megs. So if you're within the 100 meg spec, or sorry, the 100 meter
100
spec.
meter spec. Yep.
Yeah, 100 meter spec. You can do Cat 6A. You can put, your ballroom access point's going to go in, and you can do. Most of them are running at either 2.5 or 5 gigs right now. Some of them can run at 10 or up to 10. I think you're still fine. So obviously, investing for the future, if you have a choice, you could go 6A or higher and probably be good for a while. All right, next. So obviously the alternative is to run fiber. Fiber, the best thing in the world is still single mode fiber, best I can tell. Haven't seen anything surpass it yet. If you want to pull single mode fiber, and it's a little bit more expensive to terminate, with the electronics on the sides, but it's a good investment. You can pull it, and whether you're using like PON, passive optical, or active Ethernet, doesn't really matter to most anyone who's a manufacturer of an access point. Will figure out a way to connect everything up. The big thing is invest in the correct technology for your situation, and understand that your investment is how you're going to extend the life of the equipment you're buying, right? So make sure you're always utilizing the best you can. All right, next one. So I think we kind of touched on this a little bit. The uplink bandwidth between the closets, right, from that IDF to the MDF, multi-gig is almost going to be a requirement. 10 gig is just not going to get it done. Sorry, 1 gig isn't really going to get it done anymore. 10 gig is going to be necessary the more APs we put on these switches. So keep this in mind. If you have to do multiple links, you could do multiple 10 gig links to get 20 gigs or more. There's also, as I mentioned, 25 gig and up to 40 gig, actually 100 gig links between a lot of switch manufacturers have this now. So, but as Mark mentioned before, you can do one closet at a time. Just because one closet moves to 10 gigs doesn't mean they all have to move to 10 gig. You can you can spot check them. If you're monitoring your network, you can say, well, this one's running fine at 1 gig. I'll leave it. This one needs to move to 10. Let's move it to 10. But keep in mind your fiber
just don't want to get you oversubscribed, right? That's the challenge in this environment. Yep. And I think you're going to touch on the fiber.
Yep. So go ahead. Next slide. So just like the copper discussion, this is the fiber discussion. So if you have orange fiber in your property, you probably are going to want to look to upgrade it. Because it caps out at a very short distance for 10 gigs. So if you look at 1 gig, the orange OM1, OM2, you can go a pretty good distance on 1 gig, but look at those distance plummet when you get to 10 gig, right? 33 meters or 82 meters is not very far. So what you need to do is either go to OM3 or 4, which is the blue, the aqua cable, which is multi-mode, or just go straight to single mode. Really, like I said before, it's the best thing out there. You're probably not, in the life of that building, you're not going to oversubscribe a single mode fiber. So if you have the opportunity to run fiber, just go ahead and run single mode. You're probably going to need it at some point in time. That's the investment protection, in my opinion. And you can see the distances up to 25 and 40 gig and even 100 gig. I didn't put it on here, but 40 gig is probably going to be sufficient for a hotel.
Yes.
All right. Okay.
Yeah.
So and then, everything's moving up. So if we have multiple 10 gig connections coming out of the closets, we need to terminate them on the core somewhere. So our IDFs are going to be pushing more data. Now our interconnections to our core are going to have to be bigger. So our core switch is likely to be upgraded. We may have to look at the capacity on our gateways and routers, right? So, everything has to take the flood of data that's coming in. And then after we hit the next bottleneck, what's the next bottleneck? Well, what's my bandwidth to the street? Oh, I might need bigger pipes out to the street. And as hoteliers, we have to be careful to recommend that, well, I'm just going to keep it low, and so I don't have to pay for it. But the performance is going to, really suffer because it's more clients waiting in line to get out, right? It's everyone standing at the gate, and the queue is going to back up, and people who are only looking for maybe 10 megs of data are going to get stuck in line behind everyone else who needs, higher end data. So it's very important to make sure there's no bottlenecks. I know it sounds like, well, I'm just going to cut everyone down to, 30 megs and everyone will be happy. The problem is no one will be happy if everyone has 30 megs because your device is capable of doing more than that. So I think it's a very, very keen thing to keep an eye on is to make sure that we don't, bog the system down by value engineering. So I think this is an animation, Sandy.
Yeah, there it is.
So,
Yep.
so this is what you might see out in front of your property if you need to upgrade.
Yeah.
So,
I think to your point, you've got to keep, we keep doing efficiency and making the end device work better, more seamlessly, but we got to, as you said, kind of go through the stack and make sure we're considering all parts of the environment, right? That's the idea.
yeah. All right. I think the next one's the final slide. So,
Yep.
trickle up economics, right? So our good friend, Mr. Reagan, is maybe many of us grew up with. So what have we come to the conclusion is Wi-Fi improvements are going to cause stress on the existing networks, right? We know this. We feel the pressure. A few years ago, I gave a talk at one of the shows or something, a tabletop talk around this trickle up economics and how Wi-Fi 6 was going to put pressure on networks, and it definitely has. So, there's going to be improvements that are going to need to be made. Faster clients are going to bring more traffic, more applications are being added to the network, right? Even not only just looking at Facebook or looking at TikTok or whatever, there's more actual data coming in for useful apps. Mark mentioned VR. VR is going to be a thing. It's definitely moving forward. I've already seen, some real-time applications for this, even in hotels for sure. And so, these networks need to be designed for the more robust Wi-Fi technology. So we can't value engineer it. We have to look forward. We have to make sure that we're always looking to make sure that, we're not the problem. We're network people for the most part, right? We make sure that we can service the clients and service the hoteliers in the right way and make sure that we're doing the best for them. So hit the animation there. So yeah, there we go. So we're going to turn trickle up economics, turn trickle down economics upside down. And, basically what we're saying is it's going like this. You have to invest in your networks and your properties and be ready for the future. So Mark, anything to that?
That's good. No, I think you covered most of it there. The only thing I would want to add is that this discussion was kind of meant to be less of a technology discussion and not meant to scare people, which I think sometimes it can do. This was meant to open up, maybe get you thinking differently, enable you to kind of use some of these slides or concepts for discussions with your customers, with you as consultants, with your properties, with different areas, right? That's the idea of what this is for. And, hopefully that was valuable.
So I think there's one more slide after this, just a reference slide. Yeah, go ahead. So these are the Wi-Fi 7 supported devices today. This slide is probably 2 months old now. I'm sure there's probably a dozen more. Just understand that, they're out there and they're going to be more and more every day. So
Right. We don't even have the 17 on there, right? Which just came
yeah,
out.
yeah.
Exactly. That wasn't out when we did this.
Cool.
Yeah.
Scott and Mark, thanks a lot. Great presentation. A lot of great information there. I know we're at right about at time. We were hoping we'd